This is College Algebra, Unit 3, Section 3, due April 15th. This is on the algebra of functions. First, adding two functions. We've got two functions, f of x equals x minus 4, and g of x equals 4x minus 4. Addition of them, just x minus 4 plus 4x minus 4, add them together. Subtraction, be careful on it because you are subtracting the second one from the first one, meaning all of the second one will change its signs because of subtraction. We get negative 3x. Multiplication, the next thing, multiply them this time, FOIL, then combine like terms. Division, putting one over the top of the other one. You simplify if you can. Now the new part may be the composite functions. The first one, f composite of g, means we take g, whatever it is, and it's 4x minus 4, remember from up above, 4x minus 4, that is put in for the x in the x minus 4. 4x minus 4 replaces the x, and then minus the 4. The 4x minus 4 replaced the x in the other one, so it's 4x minus 4, which is 4x minus 8. The second one, g composite of f, means whatever f is, which is x minus 4, f is x minus 4, replaces the x in the 4x minus 4. So it's 4 times x minus 4 in parentheses minus 4, then we simplify. Number 4, same thing. We add the two functions together and simplify. We subtract the two functions, again, making sure you change the signs of the second one. We multiply the two together with FOIL and combine like terms, but there is no like terms. We divide the two. Then we do the composite function. First, f composite of g. We take the x minus 2 and put it in for the x in the other one. So x minus 2 replaces the x, so x minus 2 is squared. And you have to use FOIL, x minus 2 times x minus 2, and that gives you as shown there. Then you combine like terms. The second one, g composite of f, you take f, which is x squared minus 4, and put it in for the x in the second one. X squared minus 4 replaces the x in the second one, so you get x squared minus 4 minus 2, x squared minus 6. Number 6, the same way. We have 5x minus 10 and 5x minus 10. We add them together. We subtract them. We multiply them together with FOIL. We divide them. Then we find our composite function. We take g, which is 5x minus 10, and put it in for the x in the 5x minus 10. So that gives you 5 times, in parentheses, 5x minus 10, because that 5x minus 10 replaced the x, and then minus the 10, and you get 25x minus 60. The other one, g composite of f, will be exactly the same. Number 8, we have f of x is x squared minus 2, and g of x is 3x squared. We add them, we subtract them, we multiply them with the distributive property, we divide them, nothing cancels out. Then we do the first composite function. We take g, the 3x squared, and put it in for x in the first one. So 3x squared is going to be squared, 9x to the fourth minus 2. Then the second one, we take f, x squared minus 2, and put it in for the x on 3x squared. So it's 3 times x squared minus 2 squared, and again you've got to use FOIL on that x squared minus 2 squared, and we come up with the answer shown there. Number 9, x cubed and 2x squared, we add them together, we subtract them, we multiply them together, we divide them. On the division this time we find that x cubed and x squared cancel, so we have x over 2. On the first composite function, we take g, the 2x squared, and put it in for the x in x cubed. So 2x squared is going to be cubed which is 8x to the 6th. Then we take the second one, we take the composite f, we take f, x cubed, and put it in for the x, and 2x squared. So we get 2 times x cubed, which is squared, so 2x to the 6th. That's number 9. Then the next group, to prove functions are inverses, or one-to-one, we find the two composite functions. First, f composite of g has to equal x, g composite of f has to equal x. Then they are inverses of each other if that happens. If not, then they're not inverses. For instance, number 10, we take 1/7 x plus 3/7 and put it in for the x over here. And that's what I've done right here. And I worked it out algebraically. That's x. Then on g composite of f, we take the f, 7x minus 3, and put it in for the x over here. And then I simplify it as I've done right here. It also comes out to x, meaning they are inverses of each other. Number 12, I do start out with the first composite function. I take g, 2x minus 3 halves, and put it in for this x over here. When I simplify that, as I've shown here, doing the algebra, it comes out with x plus 3/4. So I don't need to go any farther. It did not come out to x. So they are not inverses of each other. Then, number 14, I have 1 over x and 1 over x. So on the first one, I take the g, 1 over x, and replace this x over here. So it's 1 divided by 1 over x. So 1 divided by 1 over x means 1 times x over 1, which is x. And the other one would be exactly the same, so they both came out to x, so they're inverses. Number 16, I take my g, square root of x, and put it in for the x over here, and then square it. Square root of x squared is x, period, plus 3. Did not come out to x, so they are not inverses of each other. Now 18 is a little more complex. 1 over 1 plus x and 1 minus x over x. First, I take this one and put it in for this x, as I show right here. Then I have a complex fraction, and what you can do on a complex fraction, where you have fractions within the fraction, is multiply every part of it, every fraction, by the common denominator, which is x. So I take x times 1, I take x times this 1, I take x times 1 minus x over x. And that simplifies to x over x plus 1 minus x, which is x. Now the second one, I take the f, 1 over 1 plus x, and put it in here for x and here for x. I substitute it in those two places, as I've shown right here. Then again, this is a complex fraction. So I multiply by the common denominator. 1 plus x here, here, and here. I multiply all parts of it as I show here. And so I get 1 plus x minus 1 over 1, which comes out to x. So they are inverses. So they are inverses. Now, if you're given an equation and you're asked to write it as an inverse, such as 3 plus 4x is our function, first thing you do is put y instead of f of x, so y equals 3 plus 4x. Then, step 2, switch x and y around. X equals 3 plus 4y. Then, do your algebra. Get your y by itself. First I subtract 3 to get 4y by itself. Then I divide by 4. And so x minus 3 over 4 is equal to the y, or to the inverse of x. And that's how you read that, the inverse of x. 22, same thing. 3 over x plus 1. First I make y equal to 3 over x plus 1. Then I switch them around. X equals 3 over y plus 1. Then, because of this denominator, I multiply by y plus 1 on each side. So xy plus x, when I multiply that out, equals 3, because the y plus 1's canceled out. So xy plus x equals 3. Then, remember, I'm trying to get y by itself. So xy equals 3 minus x. Then I divide by the x, just to be left with y. So 3 minus x over x is my inverse. 3 minus x over x is my inverse. 24, we have f of x equals x minus 3 squared. Number 1, make it y equals x minus 3 squared. Then switch around x and y, which I've done. Then I solve this for y. The y is in the side of something squared. So when what you're solving for is in something squared, take the square root of both sides. Square root of the right side, y minus 3. Square root of the left side, square root of x. Then get that y by itself, add 3 to both sides. So the square root of x plus 3 equals y. That is your inverse. Now what is an inverse? For instance, if I would have put 6 up in this equation here, 6 minus 3 is 3, squared is 9, so I get the ordered pair 6, 9. On the inverse, that means you just flip those around and 9, 6 should be working in there, which it does. The square root of 9 is 3, plus 3 is 6. That's briefly what inverses are.